All right, here we go. Your quiz will look like this. Of course, the questions will be a little bit different. Sketch. I'm on the front side now. There's two quizzes here. We'll do them both. I'm on the front side. Sketch the indicated curves. All right, so the first one is the exponential curve. So what you will do is draw the exponential curve, which looks like this, and this is the point 0, 1. That's your exponential curve. Okay? The next one. What's the next one? Absolute value. And what's the shape of an absolute value? It's the V. So you'll just draw the V. What's the last one? What curve is it? It's the square root function. And you remember what that one looks like. Get your flashcards out. If you don't, what does that one look like? Somebody do it for me in the air. Yep, it's the arc, kind of, or whatever you want to call it. Looks like that. All right, so notice there were 3 problems where you had to draw the sketch. All right, now what's going on in the next one? I drew the sketch and you tell me the name. Okay, so what is the name of 2a? What is 2a called? That's the logistic function. And it's spelled just like it sounds, so we shouldn't have any trouble spelling it. Logistic. What's b? Yeah, don't say step function. That's not what function it is. That's the kind of function that it is, but it is the greatest integer. And what about C? You've seen that one a lot over the years. Which one is that? That is the squaring function, or if you would prefer to call it quadratic function, that is fine. Okay, so in the top 3, I gave you the equation, you drew the picture. In the next 3, part 2, I gave you the picture, you gave me the name. Now what's going on in the bottom 3 there? I'm giving you the picture, but now you're telling me the equation. So for number 3, what is the equation for A? Y equals X. That's your linear function. It doesn't get any easier than that. Y equals X. That's your identity. Y equals X. What's the next one? B is the logarithmic function. Y equals ln x. That's your logarithm. Now C, oh, be careful. This one's either a sine or a cosine. Which one is it? It's cosine. Because, did I talk yesterday about original sin? Okay. Or I didn't? Yeah. Okay. Original sin. Sine, sin, S-I-N. Origin, original. Does this curve go through the origin? No. Therefore, it is not the sine. Therefore, it must be the cosine. And then number 4, my catch-all question. How many flashcards do you have? 12. I did 3, 3, and 3. So what's left over? 3 more, right? Which 3? And I've said you can either draw them, name them, or give the equation. I don't care. What are the last 3? Which ones haven't I talked about? Well, we did cosine, but we didn't do sine. So one of them is y equals sine x, the sine function. What else didn't we do? We didn't do the reciprocal function. That's 1 over x. So again, you can write the word, you can draw the picture, or you can write the equation. one more we didn't do.
The
The cubing function. Y equals x cubed. That's the cubing function. All right, now turn it over. Let's see what this quiz looks like. Oh my gosh. What does it look like? The same thing, right? Same format. I just mixed up the functions. What do you think your quiz is going to look like? Same format. So you're going to have to draw 3 pictures. So these 3, all right, what do they look like? These 3 pictures, what are they? Y equals x squared. So this is 1. What does y equals x squared look like? Y equals x squared. What's it look like? Picture. That's right, Megan. Here it is. That's your parabola. Sine x. What does sine x look like? It starts at the origin and has a hill and a valley, and a valley and a hill this way, right? That's your sine function. What does your absolute value look like? That's your V. Now, I reserve the right to pick any 3 and have you graph them. You're supposed to know the graphs. Now, number 2 says, okay, give me the names of these functions. So, what do we got in A? Well, it is a step function, but the name of it is greatest integer. We're writing the name, not the equation, the name. So you'll say greatest integer. What's B? That's your cubing function. And what's C? That's your logistic function. Write the equation of the picture. Okay, you know what we've got in A? Which function that is? It's your exponential. So it's y equals e to the x. Very good. That's your exponential. How about B? We just talked about it. B is the square root function. We're writing the equation, so that's the square root of x. And C is the reciprocal function, y equals 1 over x. So I drew 3, I named 3, I wrote the equations for 3. There's 3 more. So look on the board, what do we not have? This was the sine, this was the squaring, and this was absolute value. What have I not included in the quiz so far? Cosine. So you can either draw it or write the equation of it or name it. So I'll just say y equals cos x. That's the cosine curve. What else? The identity. Y equals x, or the identity, hasn't been included yet. Which one? The logarithmic function, which is y equals ln x. Now that last question is probably going to be the why do I always get picked up? It's probably going to be the hardest for you because you have to remember all 12 functions. And sometimes that's hard for me. I get it, but you do have to remember them. Okay? So the next time I see you, which I think is Wednesday, we'll have a quiz over this. Got it? Okay. Now, where did we leave off in our conversation? Okay, so we haven't started the new packet yet.
No.
Good. We're going to start it right now then. So get your new note sheet out. And we're going to start it right now. So the new note sheet starts with page 8. Joy? Is it an emergency? Yes. So hurry up. Hurry back. We're busy. We got math to do. What are you doing, Peter Worsley? Okay. Yeah, you can do that. All right, everybody got your note sheet out ready to go? Okay. First page is really not anything new. It's just some equations that are written weirdly. So we're going to see if we can solve these equations that are written a little bit abnormally. All right, so we have x squared minus 4x minus 1/3. Okay, how would you like to solve this equation? Trey? That will absolutely work. You want to use the quadratic formula. It's a quadratic equation. He wants to use the formula. And he wants to use the numbers 1, -4, and -1/3. Okay? Will that work? Absolutely, 100%. I am too lazy. It is Friday afternoon, long weekend. I do not want to mess around with that fraction. So what am I going to do if I really don't want to mess with the fraction? I'm going to times everything by 3. You do not have to do that. So Trey, your idea was fine. It's just more work than I want to do. So I'm going to multiply everything by 3. All that did is give me a 3x squared, a 12x, but look here. What does it give me on the end? -1. So now I can do my quadratic formula just like you suggested, Trey, but my c will not be a fraction. Remember, I have a radical. That would be under a radical. Oh my. X equals -b plus or minus the square root of. Anybody know 12 squared? 144. Minus 4 times a times c all over 2a. Now, notice the double negative. I'm grading your tests. There was a question on your tests like this, and there's a lot of arithmetic mistakes. A lot of you didn't pay attention. You have a double negative there sometimes, which means this is going to become an addition. So it's 144 plus 12 or 156. Now, you willing to stop there? I hope you're not willing to stop there. You shouldn't stop there. If you stop there, you're even lazier than me. 156, how does it break down? 2 times 78, which is 2 times 39, which is 3 times 13. So it's all broken down. I have 2, 2, 3, 13. I got 2 2's, right? So out comes a 2. 12 plus or minus 2, and inside stays 39. Now are you willing to be done? No. Heavens no. Because why? We can cancel. Marissa said divide everything by 2. So this is a 6. That'll be a 1, and that'll be a 3. You're done when you write 6 plus or minus root 39 divided by 3. That's when you're done. If you get crazy and cancel 3 into 6, you're wrong. Don't do it. You can only cancel when it's out of all 3 places. That's review. Nothing new there. Let's look at B. B is just a scary equation. What? Oh, sweetie. I know basketball started. But you know, you think about it, you got to play basketball, one of your favorite things. You end the day with math, the other one of your favorite things. There's something better than that. Okay. 3 you could have a birthday today, I suppose, yeah. All right. So how do you think we're going to start this problem? Distribute. Multiply this out? Yeah, you don't want to be messing around with this till you get that straightened out. So this side's going to be fine for a minute. All right, so what do we got over here? X squared minus 2x plus x minus 2 plus 5x. This is a big equation. Keep it straight, be organized. It was scary. I'm not doing anything over here just yet. What's happening over here? I got an x squared. Okay, I got this, this, and this. So what's that going to make? A plus 4x, you say? We okay with that? Everybody agree? All right. Now what do you think? What might be a good idea now? Move everything over so my equation is set equal to 0. So that'll mean minusing x squared, minusing 4x, and adding 2 if I move it all over to this side. So I'll be left with 2x squared minus 8x plus 4. Now I look at that. Ken? Yeah, that's what I would do. Because I'm going to go right back here where we went a minute ago to the quadratic formula. But if I can have smaller numbers, it'll just make this a lot easier for me. So I'm going to go ahead and take out a 2. I'm going to divide everything by 2. This is one of those things, just like when I was talking to Trey a minute ago. He could have used it. We didn't have to multiply by 3. We did that to make it easier for Mrs. Ford. We don't have to divide by 2. We're doing that to make it easier for Mrs. Ford because I'm old. So you got to make it as easy as you can. Now, what do I do at this point? If it factored, I would factor it. But this one is not going to factor. So what am I going to do instead? I'll use my quadratic formula again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I do not have a double negative this time. So I'm going to subtract. So 4 plus or minus the square root of what? 16 minus 8. Philip, you look like a deer with headlights. In the headlights. You good here?
Yeah, I'm good.
You're following? Okay. I know it's Friday afternoon. Everybody's counting minutes. I wish we had longer together. 16 minus 8 is 8. And that is 2 root 2. Somebody's already reduced it. Now we got 2's all over the place. So on the outside only, I'm reducing my 2's. And I'm left with 2 plus or minus root 2 as the answer to the question. That is a massive problem. But as long as we do it one step at a time, we're good. Lucas, I'm going to chain you down here. So,
It's fine.
I know.
It took a minute. My brain is
I had a group last year. They never took their medicine on Friday.
Yeah,
Fun Friday.
Fun Friday.
Do you
Yeah.
have Brenton Anderson?
Fun Friday.
Yeah, I don't know what that was about.
No, in like middle school, he wouldn't take his medicine on Fridays, and we call it Fun Friday because he was just off the charts.
Yeah, I had a room full of them last year. Okay, luckily we didn't have this rotating thing, so I had them 6 periods, so it was just 6 periods. It wasn't the end of the day yet, but. All right, what are we gonna do with this guy? We're going to distribute our X, and then what? Move the 5 to the other side. And this one actually does factor. If you are not a good factorer, or you don't notice that it factors, what can you do? The quadratic formula. I've already done that twice, so I think I'm going to go ahead and factor this one. How does it factor? But again, I'm telling you that if you don't want to factor, then use the quadratic formula. Nobody cares. So I end up with my 2 answers are 5 and -1. All right, D. Who has an idea on this one? This is our last equation, and we're going to start on some real math here. Who has an idea about this one?
Move it all over the left.
Move it around. Okay. So let me move it. So we have, let's see, so that would be 4x squared minus 15 equals 0. Now I wish that were a number like 16. That would make my life a whole lot easier. It's not. So what do you suggest?
2x.
I wish I could do that, but I can't because it's 15. You could complete the square, but remember you'd have to divide by 4 first, and that will give us a bad fraction here. So you could, I probably wouldn't. Can you still do the quadratic formula?
Yeah, put a 0 in for B.
B would have to be 0, but I'm going to show you something easier. We did some of these the other day. What if I moved my 15 back over and divided by 4? Then I'll just take the square root of both sides. And the only caution I have for you is, when you square root this, it's plus or minus. And it would be the square root of 15 over 2. Why is it over 2? Because the square root of 4? Now, if you love the quadratic formula, like I do, I like the quadratic formula a lot. Your A would be 4. I'm right here. Your A would be 4. Your B would be 0. And your C is -15. Those are the numbers you put through the quadratic formula, and this is the same answer you would come up with. Good? All right, 1-2, section 1-2, tons of information. By the way, if we're moving on to 1-2, what does that tell me about my homework?
1-1.
I should have 1-1 done. I mean, I should be doing it by the end of the weekend. I should have 1-1 done.
So does this say, this says do extra fact sheets, that's in the document?
Yes, it this. I think I included it. If I didn't, I would give it to you. Yeah, it's here. Okay. All right, so number one, which are functions? This morning in the other class, we kind of forgot how to tell. Oh, somebody's got Hollis all wound up over there. It's right after me. How do we tell if a picture is a function or not? What? Vertical line test. Very good, Ted. And who remembers what the vertical line test is? Julie?
You like put your pencil on it, doesn't hit it.
These are the vertical lines. So you can do that with your pencil. You can actually draw vertical lines down. And what's the rule? It can't cross more than once. More than once. If it hits more than once, it is not a function. If it hits more than once, it is not a function. So each of these lines just hits one time. Would you agree with me? So that one is a yes, it is a function. B is a no, because when you draw B, when you put a vertical line down through it, what happens? It hits twice, not a function. You are only a function if it hits no more than one time. How about C?
Yes.
That's a yes. How about D? No. D is a no. How about E?
Yes.
Yes. And how about F? No. Now, does anybody, we kind of zipped through those. Anybody have a question about one of them? So if I were to give you a shape like this,
No.
you would say that's a no. Does not pass the vertical line test. Okay? Now, number 2. I want you to write 2 things down. This is an extremely important concept. The idea of domain is huge. What do you think of when I say domain? Anything?
Domain.
Range. You got domain and you got range. You have X's and you have Y's. Domain is X's. When you're talking domain, you're focusing on just the X's. Okay? If you were walking down the hall and found a random function, its domain would be all real numbers. Unless it had a radical in it, or it has a denominator in it. So in other words, it's a fraction. Maybe I should say fraction. If your function does not have a radical and it does not have a fraction, then almost always its domain is going to be all real numbers. Not always, but we'll talk about the exceptions as we get to them. For now, no radical, no fraction, no problem. All real numbers. These are domain issues. Radicals, and by issues I mean red flags. If I have a problem with a radical or a problem with a fraction, I have an issue, and I've got to figure out what to do with it. So let's start looking at these domain questions. Look at number A, 2A. Does it have a radical? No. A radical is a square root sign. Does it have one? No. Does it have a fraction? No. Therefore, what is the domain for problem A? All real numbers. And you can write, literally write, all real numbers. You can use the symbol, which is this. It's like 2 vertical bars and then that big R thing over it. Or you can do what mathematicians do, and say negative infinity to positive infinity. Because doesn't that mean everything? Any of these is fine. I don't care. I want you to know the domain for problem 2A is all real numbers. And it's all real numbers because it doesn't have a radical and it doesn't have a fraction. Okay? Now, look at B. Beep, 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 beep. Here go my domain radar. Why are my domain radar going up? Because there's a radical. Now, what do I need to know about dealing with radicals? I'm going to tell you right now. Whatever is under the radical, whatever is under the radical must be greater than or equal to 0. Because why? What happens if I put something not bigger than 0 under here? I can't have a negative in there because then it becomes imaginary, and we're all about keeping it real. We're talking about functions now, kids. We're talking about functions, graphable things. They have to be real. So all I'm saying is, whatever you have under there, you're going to set greater than or equal to 0. So what's under there in problem B? X plus 5. So I will say x plus 5 greater than or equal to 0. It's that easy. Whatever is under the radical greater than or equal to 0. Then you solve it. So subtracting 5, this would say x is greater than or equal to negative 5. And again, you guys know your interval notation, so if you want to use it, that would be great. If you want to leave your answer like this, that will be fine with me. Either one of those is fine. All right, look at C. Those radar are back up because what do we have in C? We have a fraction. And the rule for fractions, denominator cannot be equal to 0. So you look at your problem, you say, oh, I have a denominator. So the denominator cannot be equal to 0. These are the rules, kids. You have got to know this and this. If you know those, you can do every domain question that I'm going to ask you to do. Okay, so here we go. If x plus 5 cannot be 0, then x cannot be negative 5. Would you agree with that? Just subtract it from both sides. So you can write your answer this way, or if you're feeling really mathematical, you can write it this way.
Is that interval notation?
This is interval notation. This says go take negative infinity to negative 5, and then take negative 5 to positive infinity, but don't include negative 5. That's the number we left out.
Well, we don't need to.
No, you write it this way, or you write it this way. Those are the two acceptable ways of writing the answer.
Okay.
And you may use either one. All right, we're going to try to do 2 more, and then we'll be done. How about this one? 3x plus 1 over 4x minus 1. Question says, what's the domain? Why are my radar up? Because there's a fraction. And what's the rule for fraction?
0.
Denominator cannot be 0. Which means 4x cannot be 1. And cannot be 1/4. So what's my domain? X can't be 1/4. That's right.
So you just calculated with the numerator?
Yeah, nothing with the numerator at this point. Now, will the numerator have an impact on other things? Yes, but not domain. And right now I'm dealing with domain, and these are the two things that impact domain. Okay, now the last one. This is a tricky one. This is going to blow your mind, so it's a good way to end, I guess. The function is x squared over 3x squared plus 1. Now, the domain is always all real numbers unless there's a problem, right? And what are the problems? Radicals or denominators? Well, shooty, I got a denominator. So I know that my denominator cannot be 0. That's the rule. You say, Miss Ford, I can't memorize all these rules. Sorry, you have to memorize the rules. So 3x squared equals -1, and x squared equals -1/3. I do not like where this is going. Where is this going? What's going to happen when I take the square root over here, people?
It's gonna be 3.
It's going to be imaginary
Oh.
because there's a negative there. And when I take the square root, aren't I going to end up with some I thing?
Yeah.
And what did I tell you? We're keeping everything real. So therefore, remember, the problem was this denominator. As it turns out, the denominator's not a problem because it takes me into imaginary. Your domain is all real numbers. For this problem, your domain is all real numbers. What you thought was going to be a problem turned out to not be a problem. All right. You got a lot to keep you busy.
Perfect timing.